Welcome everybody. Our work is entitled on the use of stable isostress method in the prediction of creep behavior of polyamide 6. Introduction. One of the numerical problems encountered with the stable isostress method in the construction of the long-term creep curve of plastic material is the difficult handling and processing of the experimental data. The choice of fit-in functions and the identification of their parameters are also a delicate task. Objectives: construction of the master curve using the stable isostress method. 3 extrapolation functions will be tested. An improved method for solving the optimization problems will be used. A numerical routine is developed to estimate and perform all the corresponding type shifting operations. For this purpose, we use a stress testing machine to test the samples with dimensions shown in figure. Starting with 5 megapascal as initial value, the sample is subject to an increased load of 5 megapascal every 2 hours until 30 megapascal. And to facilitate a complex calculation, we developed a numerical routine to save time and minimize the errors. Also, the use of Levenberg-Markov algorithm allows to overcome the limited use of data points in extrapolation process and leads to excellent convergence and accuracy. So, to create the master curve, the experimental results are processed in 3 stages. The most important is the calculation of the rescaling time. For that, we have implemented 3 functions as it seems, and Levenberg-Markov technique used. First row of the table shows that the power and exponential functions respectively are close to 0 value, in the contrast with the higher error assessed by the third polynomial function. The present table shows that the exponential function gives the long rescaling time in the most stress level compared to the other functions. This is what allows us to obtain a rescaling curve for each load separately. The numerical process reveals that the magnitude of the shift factor is strongly affected by the accuracy of the inverse of the rescaling time in one hand, and has a proportional relationship with dwell time in the other hand. Final results of the master curves show a clear difference in the prediction time, where the exponential function has proven its quality and accuracy compared to the rest. Conclusion: 3 fitting functions are developed and examined through the construction of the master curve. The assessment of the selected parameters of the fitted models requires an improved numerical solving method to be considered. The handling and processing of the SSM data have been performed automatically, where a combinational subroutine is developed. However, larger shift factors for the exponential function are obtained, and therefore larger long-term master curves were estimated with a very close agreement.